Assalamu alaikum. In this video, we compiled or run three machine learning algorithms: K-nearest neighbor, logistic regression, and random forest, and executed these codes using the complete dataset, and we report the execution time of 5 runs. To implement the machine learning algorithms KNN, logistic regression, and random forest, we are using dataset as input. We collect datasets from the website USCI Machine Learning Repository. Here we select a balloon dataset from the website. The number of instances are 4,177 rows. The number of attributes are 8. A balloon dataset is a combination of both numeric and character form, and its attributes are types are particular, integer, and real. This is a balloon dataset. For compilation, we use the system Intel Core i5 and the version of operating system is Ubuntu 20.04.1. The compilation is done on Ubuntu 20.04.1 on the terminal by running various commands. First, we compile K-nearest neighbor algorithm, and this algorithm is implemented on Python. We perform K-nearest neighbor KNN classification and build KNN classifier using Python skit-learn package. This code gives the accuracy of KNN classifier algorithm and measures the execution time of the algorithm. Now first we look at this code and understand it. Import Panda as PID is the library to my Python script. Import time is a library to measure the time. Then K-neighbor classifier is used to import K-nearest neighbor classifier model. Train test selection library is used to import train test split function. Matrices library is used for accuracy calculation. Start time function is used to calculate the starting time of this code. The time starts from here. This read line reads a dataset from text file, then convert a text file of dataset into an Excel file CSV. Column names are given on the datasets. This line gives a column name to a CSV file of a dataset. Then here we extract some features from the dataset. Then we split our dataset into a training set and test set to understand the model performance, dividing the dataset into a training set and a test set. Then we create a KNN classifier function and then train the model using the training set, and then we predict the response for a test dataset. Then we print the accuracy of the KNN classifier algorithm. This is the end time function which calculates the end time of the code, and then we print the end time. Now we compile this code at terminal by typing various commands. Here is the output of the code. Now we run this code 5 times to monitor the execution time. From the first time compilation, it gives accuracy 0.03411 something, and the execution time is 0.18758. Now we compile for the second time. From the second time, it gives accuracy 0.03411 and the execution time is 0.188651. Now we compile for the third time. From the third time, it gives accuracy 0.03411 and the execution time is 0.1854600. Now we compile for the fourth time. For the fourth time, it gives accuracy 0.034111 and the execution time is 0.1678. Now we compile for the fifth time. For the fifth time, it gives accuracy 0.03411 and the execution time now is 0.19. You can see that the execution time is increased to 0.19. Now we look at logistic regression code in Python. This code is also implemented in Python. This algorithm is also gives the accuracy and execution time of the code. In this code, we use the logistic regression classifier model to train the data. To understand the model performance, we dividing the data set into a training set and test set. Here we create logistic regression classifier function that train the model using the training set, and then we predict the response for test data set. At the last, here we print the accuracy and the execution time. Now we compile this code on terminal. Here is the output of the code. Now we run this code 5 times to monitor the execution time. For the first compilation, it gives accuracy 0.0257 and the execution time is 12.0209. Now we compile for the second time. For the second compilation, it gives the accuracy 0.02573 and the execution time is 12.0695. Now we compile for the third time. From the third compilation, it gives accuracy 0.025733 and the execution time is 12.0141. Now we compile for the fourth time. From the fourth time, it gives accuracy 0.02573 and the execution time is 12.2091. Now we compile for the fifth time. From the fifth compilation, it gives accuracy 0.0257 and the execution time is 11.7586. Here you can see that at the execution time is decrease, means that the execution time is less as compared to the previous 11.75. Previous it gives 12.209 something and now it's 11.7586 execution time. Now we look at the random forest code in Python. Now we look at a random forest code. This code is also implemented in Python. This algorithm also gives the accuracy and measure the execution time of the code. In this code, we use the random forest classifier model to train the data. To understand the model performance, we dividing the data set into a training set and test set. Here we create random forest classifier function and then train the model using the training set and then we predict the response for test data set. At the last here we print accuracy and the execution time. Now we compile this code on terminal. Next week. From the first compilation, we see that it gives accuracy 0.045 something and the execution time is 44.39. Now we compile for the second time. From the second compilation, it gives accuracy 0.0466 and the execution time is 9.82721. Now we compile for the third time. From the third compilation, we see that it gives accuracy 0.0478 and the execution time is 7.590639. Now we compile for the fourth time. For the fourth compilation, it gives accuracy 0.04189 and the execution time is 7.3486. Now we compile for the fifth time. Now for the fifth compilation, it gives accuracy 0.0478 and the execution time is 7.4518. Now you can see that that the execution time is less 7.45 as compared to for the first compilation that it gives accuracy 44.39. Now it becomes 7.45180. Thank you.